Hello mathematicians, we're now going to revisit equations that are reducible to quadratics. We have come across these before, and what it is that we use the techniques for solving quadratic equations with equations that are made easier by making substitutions. So let's have a look at examples. It's the simplest way to proceed. So I'll do the first example in the fully formal set out by making the substitution, and then after that I expect a lot of you, I know, but I'm going to expect you to do it without doing a formal substitution. But for this first one, if we let u equals x squared, I mean, this is where the key thinking is. How do I know to let u equal x squared? And I'm looking, it looks vaguely like a quadratic, and if I can see that I have something squared and something and maybe some constants, then I've got a quadratic. So the key bit is to realise that x to the fourth is x squared squared. So if I've let u equal x squared, that gives me u squared minus 13u plus 36 equals 0. I solve that, try products and sums first. So they're two numbers that multiply to 36 and add to minus 9, and there are. So u minus 9 and u minus 4 equals 0. So these two factors give us that the roots are u equals 9 and u equals 4. Then we have to go back and change the variable back again. So x squared equals 9 or x squared equals 4. Therefore x equals plus or minus 3 and x equals plus or minus 2. And we've got 4 solutions, which fits with the fact that we've got a power of 4 up here. Now for this one here, I'm not going to do the substitution, but we look at it. How do we know it's a quadratic? Well, it's really just practice in a way. So, and maybe the first step in the practice is to go back to our algebra and say, well, I've got a fraction here, really don't like fractions. I've got an equal sign. What's my technique? My technique is multiply every term by the common denominator. So x cubed times x cubed will give me, well, the simplest thing is that it's x cubed squared, but I'll write it as x to the 6th plus 27 equals 28x cubed, and then rearrange that to give me x to the 6th minus 28x cubed plus 27 equals 0. And at this point here, I have to recognise that x to the 6th is x cubed squared. And so what I can write is simply, I can do all of this stuff and risk not changing the variable back again, but I would be really much happier if you can do this. So just write it like this, more legibly, and recognise that if I can think of two numbers that multiply to minus 27 and add to minus 28, so that would be minus 27 and minus 1, then what I've got is x cubed minus 27 and x cubed minus 1. So be really sure that you understand what I've done there. Ask me if it doesn't make any sense, but that just saves a change of variable in there. And now, as always, if we've got two things that multiply to equal 0, so this is why we do factorisation, what's the value of x that makes either or both of these brackets 0? Well, from this one, x will equal 3, because 3 cubed will give me 27, so it will make that one 0. And from this one, x cubed has to equal plus 1, so x equals 1. So there, even though this is a cubic equation, there are only two solutions to this one. Now for this next one, our first thought has to be, I can't just straight away look at that and see how the quadratic will form. Well, I can, but we need practice. So if I multiply right through by x squared minus 4x, because I don't like fractions, then I'll get x squared minus 4x all squared plus 8 times x squared minus 4x equals 48. So that is going to give me this. So I'll bring it all to one side because I have to have it equal to 0. And I can see I've got something squared, something, and in this case I've got some constants. So I can put this as u, as I said previously, or I can just say I've got a quadratic. I want two numbers that multiply to minus 48, add to plus 8. So I could have 12 and minus 4. And what goes in here? What goes in here is the thing that's being squared. So it's x squared minus 4x plus 12 and x squared minus 4x minus 4. Now that in turn gives me two more quadratics to solve. So if I look at this, are there two numbers that multiply to 12 and add to minus 4? And there are. So that's this quadratic here is x minus 6 times x plus 2. With this next one, two numbers that multiply to minus 4 and add to minus 2. Yep. No. Oops. No, there aren't. So I can't think of two numbers. Does it mean that they don't exist? Well, I go back to the quadratic formula. I do a little check. What's the discriminant? The discriminant is minus b. The discriminant is b squared, which is 16 minus 4 squared, minus 4ac. So 16 minus 4 times 1 times minus 4, which is another plus 16. So square root of 32. Now that's doable, but what it does mean is that for this part here, I'm going to have to use the quadratic formula to factor it. So if I just leave that sitting there for a moment, I can get two of my solutions here. So x equals 6 or minus 2. But for this one here, x will equal, now I have to go through my full quadratic formula. So minus b, so minus minus 4, plus or minus the square root of b squared, as we said, minus 4 squared, 16, minus 4 times minus 4, which is that, over 2a, so 4 plus or minus root 32. Now root 32 is 4 root 2, that's all over 2, so that becomes 2 plus or minus 2 root 2. So I have four solutions, that, and these two. Okay, a good example of a mix of techniques. Now, last one we look at, really common exam question. How do I look at that and know that it's a quadratic? I look at it and I realise I've seen ones like it before. Clearly there's something about this, and the something, when the penny drops, is that 3 to the 2x is the same as 3 to the x squared, because we multiply the powers together. And once I know that this is 3 to the x squared minus 12 times 3 to the x plus 27, then I've got something squared, something to a single power, maybe some constants. So, are there two numbers that will multiply to plus 27 and add to minus 12? And there are, minus 9 and minus 3. So, minus 9 and minus 3. What goes in here? The thing which is squared. So 3 to the x and 3 to the x. Then, what is it that makes either or both of these 0? Well, for this one, x is clearly equal to 2. And for this one, x is going to be equal to 1. So there are two solutions. X equals 2 and 1. So have a go at these. As always, if you're finding the early ones really easy, go on to the more difficult ones.